Okay, good day. Welcome to today's tutorial. So, just to demonstrate what will be happening in the series that will be coming up, I just want to let us know how to solve some problems in these critical areas that are essential in engineering mathematics. So you need to know algebra, you need to know indices, you need to know geometry, you need to know trigonometry, differentiation, integration, stats, and probability if you want to do very well in engineering mathematics. Of course, there are other areas, but at least your knowledge of these ones grants you a good ticket to doing very well in the other areas. So very quickly, I'm going to be demonstrating with quick examples how to solve problems in these areas. Okay, so let's start with algebra. So in algebra, you are to find if x over y is equal to 6 over 5. So we are asked to find x squared plus y squared over x squared minus y squared. Okay, so if you want to solve this problem, there are different ways of doing it. Remember, x over y is equal to 6 over 5. So if they give me x squared plus y squared over x squared minus y squared, one thing I can do is I can decide to divide all terms by y squared. So in dividing through by y squared, you have something like this: x squared over y squared plus 1 divided by x squared over y squared minus 1. So let me come over to this line. So x squared over y squared can still be transformed as x over y all squared plus 1 divided by, and the same thing will apply to the denominator, x over y all squared minus 1. So you can now replace x over y by the value given to us in the initial definition of the equation. So you have 6 over 5 all squared plus 1 divided by 6 over 5 all squared minus 1. So if you resolve this, you should get 36 plus 25 over 25 divided by 36 minus 25 over 25. And if we do the cancellation of common denominators, you will be left with at the end of the day 36 plus 25 is a 61, and 36 minus 25 is an 11. So the answer to this problem is 61 over 11. So there is, of course, another way that you can decide to solve this problem. For instance, apart from this way I just showed you here. So sorry, let me quickly clear the screen. So now, since x over y is equal to 6 over 5, you can now use the relational positions of x and y to define x as 6 and y as 5. So you can now plug it into the equation. So you have 6 squared plus 5 squared over 6 squared minus 5 squared. So this is 36 plus 25 over 36 minus 25, and this is 61 over 11. So just like we got the previous time. So this is just a little introduction to algebra problems. Okay, so we'll go to the next one. So we are solving indices. Now, indices. So I'll just take a few examples from indices. So if n is an integer, okay, so what is the least value of n such that 1 over 3 raised to the power of n is less than 0.01. Okay, so let's attempt this. So we want to find the least value of n such that 1 over 3 raised to the power of n is less than 0.01. Okay, so what do we exactly mean by indices? We mean when the number is raised to a particular power, that brings about indices. So the power could be a number or it could be a variable itself, but whichever the case is, let's solve this problem quickly. So 0.01. Now, to make this problem very convenient for you to solve, you can decide to resolve it this way. So this is still the same thing as 1 over 3 raised to the power of n, and it's less than 1 over 100. So I'm going to take the reciprocal of both sides. So when we take the reciprocal of both sides, we'll have 3 raised to the power of n, then greater than 100. Remember that whenever you take the reciprocal of both sides, then an inequality will reverse its direction or polarity. So now the question, I can now interpret the question as they asking me to find the least value of n such that 3 raised to the power of n is strictly greater than 100. So you can now interpolate for different values of n. So 3 raised to the power of 1 is 3, 3 raised to the power of 2 is 9, 3 raised to the power of 3 is 27, 3 raised to the power of 4 is 81, 3 raised to the power of 5 is 2, 4, 3, and 3 raised to the power of 6 is 7, 29. Oh, why am I even continuing? I've already gotten this particular one. So this is the first value that when I raise 3 to the power of a particular number, it becomes greater than 100. So the answer to this problem is n is equal to 5. So n is the least value that will either make 3 raised to the power of n strictly greater than 100, or 1 over 3 raised to the power of n to be strictly less than 0.01. So let's move on to a second example in indices. So in the second example for indices, we are given 4x, y, 3 plus x cube minus y cube all square to resolve. So solution. So they want us to resolve it into a more simpler form. So how do you resolve something like this? So to resolve something like this, you need to be conversant with some identities. Okay, so one of the identities I want to employ here is a minus b all raised to the power of 2 is the same thing as a square plus a square minus, it's a minus there, a square minus 2ab plus b square. And another identity I'm going to use is a plus b all squared is equal to a square plus 2ab plus b square. Now, so given this problem, you have 4xy to the power of 3 plus, so we can now expand x cube minus y cube all squared using the first identity. So follow me. I'll have x cube all squared, then minus 2x cube y cube, then what do we have? Then plus y cube all squared. So if you resolve this particular question further, you can get 4xy cube plus x cube all squared. Now I'm interested in this term most importantly, so I'll resolve it as 2. Now law of indices will take place here. In law of indices, you can still write x cube y cube as xy all cube, okay, plus y cube all squared. Now having written it like this, this two becomes algebraically alike. So it's just like saying 4 mangoes minus 2 mangoes, and that should give me a positive 2 mangoes. So this is still the same thing as s cube all squared plus xy all cube plus y cube all squared. Now if you now trace this one back to this identity, you will discover that what we have is that this is still equal to x cube plus y cube all squared. So this is the final answer for resolving this particular problem. So let's move on to another one. So another problem that we want to be considering is problems in geometry, number 3. So just interested in coordinate geometry. Geometry has different aspects. We have spherical trigonometry, we have trigonometry, we have cycle geometry, we have coordinate geometry, or the linear geometry, which is the one that we're going to treat now. So linear. Okay, so let's assume that you want to solve this question. What is the x-intercept of the equation? So let's change the ink now. So the equation given to us is 2x plus y equal to 7. Now there are 3 ways of solving this particular problem. Okay, there could be more than 3, but I see 3 ways of solving this problem. So way 1, if you want to find the x-intercept, you can put y equal to 0. So when you put y equal to 0, in order to determine the x-intercept, you get 2x is equal to 7. So x becomes 7 over 2. So this is way 1. This is the x-intercept. So way 2, you can make x the subject of the formula. Make x subject. So in making x subject, this is what we have. We have 2x plus y is equal to 7. So 2x is equal to minus y plus 7. So x, of course, is now equal to minus y over 2 plus 7 over 2. So any number here is acting as the x-intercept. That's after making x the subject of the formula. So with 3, you can make y the subject of the formula. Now when you make y subject, you have y is equal to negative 2x plus 7. So factorize the right hand side. Okay, factor it out by the coefficient of x. So y becomes negative 2 into x minus 7 over 2. Okay, now if we illustrate this particular function on a graph, we're going to be getting this. Here will be 7, and here will be 7 over 2. Is that okay? And the slope, of course, is minus 2. So this is y, and this is the x-axis. Okay, so it means that the point where this line cuts the x-axis is at the point 7 over 2. So the x-intercept, according to this particular case, which I'm going to treat more later on in the course of this tutorial, is 7 over 2. So we got 7 over 2 in all cases. So that's about geometry. Then let's come to trigonometry. I hope I spelled that correctly. So trigonometry. So to solve or simplify for instance, you're given something like sine square theta over 1 plus cos theta. So these are one of my favorite problems, and I'm going to show you how to resolve it. Now, to solve a problem like this, you need to remember that sine square theta plus cos square theta is equal to unity 1 in this case. So for instance, if I want to find sine square theta, sorry about that, I want to find sine square theta from the ultimate identity that we have already remembered. You can get it by saying 1 minus cos square theta. So you can now replace it over there in the equation. 1 plus cos theta is still the same thing as 1 minus cos square theta over 1 plus cos theta. Now you also need to remember another rule. So remember difference of two squares. Difference of two squares. And difference of two squares basically tells me x square minus y square is x minus y, x plus y. So that is difference of two squares. So you can see that in the numerator, 1 minus cos square theta can be factorized as difference of two squares, because what I'm saying is 1 is still 1 square and cos square theta is also a square, so you have 1 plus cos theta. So this is resolved as 1 minus cos theta and 1 plus cos theta over 1 plus cos theta. So at the end of the day, you can now see some cancellations, and you're now left with 1 minus cos theta as the final answer. So this is just a little about trigonometry. Then let's come to differentiation. So to introduce us to differentiation, we are going to find dy by dx, given that y is equal to cos 3x plus exponential 2x plus ln cos x. Sorry about that. I'm going to write it very well. It's going to fit in. Okay. So let me write it again. Y is equal to cos 3x plus exponential 2x plus natural logarithm of cos x plus arc sine or sine inverse of 3x. Okay, so you want to solve something like this, for instance. So you need to remember the principles of differentiation. So dy dx, for differentiating cos 3x, I'll have definitely a minus 3 sine 3x from chain rule. Then differentiating exponential 2x, yeah, you need to differentiate 2x first, and it gives you 2, and you return exponential 2x. Then in differentiating ln cos x, differentiating ln cos x gives me negative sine x over cos x. Then in differentiating sine inverse of 3x is going to give me 3 all over the square root of 1 minus, sorry about that, 1 minus 3x all squared. So If we organize the answer, we have minus 3 sine 3x plus 2 exponential 2x, then now have minus sine x over cos x is the tan x, and now have plus 3 over the square root of 1 minus 9x squared. Okay, so this is the answer. This is dy dx. So don't worry much about differentiation for now. Just mark this somewhere if you don't understand it fully. We have a full package that is being prepared on differentiation from first principles. Okay, then 6, integration. So integration, so for instance, you're asked to solve the integral of x squared exponential x cubed dx. So you want to resolve this integral. So how do you go about it? Now, first of all, one of the ways I normally tackle this kind of problem is I find a source. What do I mean by a source? Dx. So you need to observe x cubed in this particular term. When we d by dx of x cubed, we get 3x squared. So in other words, d of x cubed is equal to 3x squared dx. So you can now discover that from this equation that we are given, if there is a way we could somehow manipulate this integral such that it looks like what I just got here, then I'll probably be good to go. So let me just quickly manipulate the integral. So in manipulating the integral, I'll have the integral of exponential x cubed, right? Then dot 3, and I'll put a 1 over 3 outside, then x squared dx. So I've now gotten this term here. So matter cannot be created nor destroyed, right? Yeah, so I introduced a 3 here, and as a countermeasure I introduced a 1 over 3 outside the bracket of the integration. This is mathematically allowed and it is valid. So if you go further in simplification, you have 1 over 3 an integral of exponential x cubed. Then this whole term 3x squared dx can be replaced by d of x cubed. Okay, so now you want to perform this integral, and if you're performing this integral, you will agree with me later on in this course that the answer to this is just exponential x cubed then plus constant of integration. So this is where you stop integrating. So whenever we integrate, we always return a constant of integration, c, unless we are dealing with definite integrals where the integration has limits, maybe something like an a and a b, and in that case we don't have to return a constant of integration. But whenever we integrate without those limits, we must return the constant of integration. So finally, the last question for today is on statistics and probability. So just a simple problem, number 7, probability. So in stats and probability, the question that we have to take is if a coin is tossed 10 times, what is the probability of obtaining 6 heads? So So now remember, all what I've done so far is just demonstrations. So whether you understand or you don't understand fully, I just want you to be rest assured that I'll make it an aim to break all these things down as we go further into these tutorial packages. Now let's solve this problem. First of all, you need to know that this kind of probability cannot be solved manually. If you try to solve it manually, by manually I mean like analyzing it one after the other, you need to use some formula, and the formula that we're going to use is we're going to use the binomial probability formula. P of r is equal to n combination r, and p raised to the power of r, and q raised to the power of n minus r. So this is the binomial probability when you're dealing with outcomes that can contain two possible values. So in our case, whenever you toss a coin, there are two possible scenarios. It's either you get a head, or it's either you wind up with a tail. And in all cases, the probability of success, which is the small letter p that you're seeing here, is going to be 1 over 2, and the probability of failure, q, is 1 minus the probability of success, which is what? 1 over 2. That is when we solve 1 minus 1 over 2, we'll still get 1 over 2. So if they want me to find the probability of obtaining 6 heads, that means they want me to calculate P of R equal to 6. This is a capital letter P, okay? This is a capital letter P, and this is a small letter p. So remember, n is standing for the number of times the test was carried out. So r is standing for 6, 10 combination 6, p being 1 over 2 raised to the power of 6, then q is 1 over 2 raised to the power of 10 minus 6. So this will land me at my answer. So P of r equal to 6 is equal to 10 combination 6. So you can, there are various ways of solving 10 combination 6, but we're not going to use the manual way of solving it because of time. I'm just going to punch that on my calculator. Give me a second. 10 combination 6, 10 combination 6, 10 combination 6. So 10 combination 6, so that's 210. So if you have a scientific calculator, you can quickly punch that. So you have 210, then 1 over 2 raised to the power of 6, and this will be 1 over 2 raised to the power of 4. So we have 210. If you use the law of indices, this becomes 1 over 2 raised to the power of, since we have 1 over 2 and 1 over 2 in both cases, then the indices we add 6 plus 4 is a 10. So this is 210 divided by 2 raised to the power of 10. 2 raised to the power of 10 should be 1024. Of course, 1024. So this should be 210 is 105, 512, and you can keep dividing and dividing and dividing as the case may allow you to keep going. So this is the probability that 6 heads will be obtained when you try tossing a coin 10 times. This is just a little hint of statistics and probability. Now we've come to the end of this demonstration. I know some of the concepts may look strange. It is expected at first to look strange. So join me in other tutorials as I'm going to be demystifying most of the concepts I explained previously, and I believe that you will understand because I am here to make you understand. So I want to be the solution to your problem. So don't forget to like this video and subscribe, share the video, click on the notification button to receive more updates.